Hello, welcome to the short presentation of my doctoral paper, A Role-Based Architecture for Self-Adaptive Cyber-Physical Systems. In this presentation, I'd like to give you an overview of my current plans for my PhD thesis. The presentation is lined out like this. I'd like to start with a short introduction on myself. Then for the actual talk, I will start by explaining the motivation behind my thesis, and then I will talk about the concept and how I want to evaluate the contributions of the thesis. The final part of the talk will be a short overview on related work and a conclusion. And regarding myself, I am Tim Kluge. I'm a PhD student at Technische Universität Dresden, and I'm currently in the first year of my PhD. The doctoral paper I wrote and present here is a representation of my early ideas and plans, and this is the first conference I ever attend. I'm a member of a larger research training group called ROSI, which is short for Role-Based Software Infrastructures. The overall goal of ROSI is to model and implement software systems that use role-based and context-aware programming. I'm also interested in concurrent and distributed programming, which is related to my PhD topic as I'm currently planning it. So for the actual talk, as you all know, the number of smart connected devices and cyber-physical systems in existence is rapidly rising. Software is continuously expanding into all parts of everyday life, and the complexity of the systems is continuously increasing as well. However, with rising complexity, the software is becoming harder to maintain, and the probability of the introduction of errors rises. When we are talking about the complexity, we can divide complexity into two categories: accidentally and actual complexity. The actual complexity describes how complex the real-world system is in terms of how many concepts are described. In contrast, the accidental complexity is complexity that is introduced by the implementation of the systems and is undesired. For example, when developing a software with object-oriented programming, we might need some adapter classes that serve no actual purpose in the real world but are necessary for the realization. As such, it should be a goal to minimize this complexity. In the survey on development challenges of self-adaptive systems, Waynes et al. Also identified the management of complexity in cyber-physical systems as an open issue. So, like I said, accidental complexity is introduced when system models do not accurately represent the real world. One central aspect that is often not modeled is context. A context model can include all parts of environmental information. As a very simple example, the weather. The context has an impact on other entities in the system that are expected to adapt to the changing conditions described by the context. The context-dependent parts of objects are called roles. Objects can dynamically play and drop roles at runtime. As a simple example, on the right side of the slide I depicted an example context model of a convoy of autonomous cars. On the left side you have a car object which defines a single car. It may have some attributes like the speed it is traveling at, and the target speed, which is the speed it intends to travel at. Now on the right side, a context waning is modeled. In this context, a car may play the role of a slow driver. The slow driver alters the behavior of the car and overrides its target speed. Below that, a context called convoy is depicted, which describes the convoy formed by the autonomous cars. In every convoy, there's a role leader and a role participant. So to summarize, to reduce the accidental complexity, we have to more accurately describe the real world. And because in the real world, objects dynamically evolve depending on the context they are in, context and roles should be modeled. So I did not talk about the specific problem that I myself want to deal with yet. The problem is that current approaches to role-based programming are not distributed. If you want to write a software that employs roles, you can use a variety of dedicated languages or frameworks. However, these approaches enable role-based programming on a single node only. If you want to write a distributed application like the convoy example, you are limited to writing individual parts and connect them on your own. This is why I want to contribute and try to provide a framework or programming environment for distributed role-oriented programming. I expressed that as a research question on this slide here. Currently, I am thinking about extending the actor model with roles. If you do not know about the actor model, I have depicted a simple explanation on the right side of the slide here. The actor model is a concurrency model where you have a number of so-called actors, which are independent entities that communicate only via message passing. My first goal would therefore be to evaluate how well actors can be integrated with role programming, and if the combination of the two concepts makes sense to build a framework for actor programming with roles. In terms of time scheduling of my PhD project, I would like to invest the remaining months of 2020 for this. The next question I want to deal with is how to adapt the system. Since the system is modeled with roles, adapting the system to changed circumstances means adding and dropping role plays. For example, in the car convoy example, the adaptation to rain would mean to add a role play to the car base object in the rain context. But the question is when to add or remove roles, which I expressed here as a research question number 2. An interesting approach to that, which I want to investigate, is graph rewriting on the context model. With graph rewriting, you would be able to define rules that match a certain pattern in the model and replace, modify, or drop it entirely. So as an example, in the car convoy example, multiple autonomous cars form a car convoy, which is modeled as a context. In the structural model, it was not defined when the car convoy context should actually be formed, and with graph rewriting, you could define a rule that describes that. I depicted an example for this on the slide, which is expressed as a pseudo-datalog rule here. The role plays, context presence, and additional properties like the distance between the cars are expressed as logical predicates. Obviously, this needs much more thought, but I think the general approach is worth an investigation. As the definition of adaptations would be very concise, it would fit the overall goal of reducing the system complexity. And regarding the schedule, I would like to spend the majority of 2021 for this idea as well as the evaluation. The goal would then be to extend my distributed role programming framework with graph rewriting rules as an adaptation mechanism. Because my current PhD contract terminates in late 2022, I would plan to invest that year into fixing open issues and then writing the thesis. As I said, the goal of the system would be to reduce the accidental and thus overall complexity of cyber-physical systems by including contexts and roles in the model and providing means to implement software that uses them. Of course, the claim that using roles and context like this can reduce the complexity has to be evaluated, and I'd like to conduct multiple case studies for that. As a starter, the basic car convoy example introduced in the motivation would be a good starting point for a multiple prototype, I think. After doing that, I'd like to proceed with a more complex real-world example where a robot arm and a human collaborate to perform a task, for example, placing a bottle on the tablet. Finally, I'd like to contribute the implementation of a solution to the DARTSIM benchmark for self-adaptive systems that was presented at the SEAMS last year. In DARTSIM, a fleet of unmanned aerial vehicles are tasked with a certain objective and have to adapt to changing circumstances. Because there are many other implementations available, a direct quantitative comparison in terms of complexity and adaptation performance would be possible. So the DARTSIM case study would be the most important case study, and as I see it now, the main part of the evaluation of supporting the claim that building self-adaptive systems with distributed roles and context can lower the complexity compared to not using context. Regarding related work, the main part that the thesis would build on are the existing solutions to local role-based programming, namely object teams and scroll. Also of interest is research done on the actor model as well as current implementations of it, for example, the actor framework. For the second research question, which was about the planning of adaptations, there is some existing research on using graph rewriting for architectural self-adaptation. A system that is very related to what I want to do is the eco component model, which features a special kind of context called ensemble, which is very related to what I want to achieve. So to conclude, I want to stress that the complexity of cyber-physical systems is an issue that can be partially addressed by reducing the accidental complexity of the systems. The accidental complexity can be reduced by more accurately representing the real world. Because in the real world, objects behave differently in specific contexts, this should be reflected in the system models by explicitly modeling context and roles. And currently, there is no general purpose environment for distributed role-based programming. This is the main thing that I want to address in my thesis. So the goal is to provide a framework for distributed role programming. With the resulting system, I want to show that the complexity of implemented software is lower than the complexity of equivalent implementations that do not use roles. As a benchmark for that, I intend to use DARTSIM. In the system, I plan to use graph rewriting on the context model to express adaptations. The whole thesis project is expected to be done by the end of September 2022. Thank you very much for watching this video in advance of the SEAMS conference, and I am looking forward to meeting you there.